Hey there, I'm Rob, and I'm here to talk to you today about Vault Reliability Engineering. Now, before I get into what that is, allow me to tell you a story. And this is a common story across organizations when adopting any type of platform, system, or tool. So the business will commission a proof of concept of whatever this platform or system is. So there'll be a team responsible for conducting that proof of concept. They'll experiment, they'll put something working together and present it to the business. Now, the goal of this exercise is to demonstrate business value to the decision makers. If the tool, the platform or system is in fact delivering business value and the team has done a good job in demonstrating that, then generally speaking, there will be buy-in from the decision makers. After that phase has happened, there tends to be some business activities like procurement of licenses and so on and so forth if it's not an open source system. Once all those things have been done, generally speaking, the business will say to the team responsible for managing the proof of concept to do what it takes to make that system production ready. So that could be about scale. It also could be about security hardening and so on and so forth, right? So whatever production ready means for that tool, product or platform to that specific organization according to their business and security posture. So we now have a new platform in place within the organization, and generally speaking, there will be some early adopters. These early adopters will recognize the value that it will bring to their deliverables and will be eager to onboard and actively engage in its rollout. So these early adopters tend to be almost like your internal developer advocates. As word begins to spread around the organization about the benefits of this newly released tool within the organization, you'll have more and more engineering functions that want to extract the same value for their deliverables. They want to buy into this new thing that's been released. So when that happens, essentially all these teams are working with a centralized team, the team that was responsible for the proof of concept, to onboard their teams and applications. And that is where the problem starts to arise. So what we have is a team that once upon a time could manage the scale of demands, but as that scale has increased, the team size has not. And as a human being, we only have a certain amount of hours in a day that we can expend to doing these things. So that starts to affect developer productivity. If your developers are relying on the service from the centralized team and they're not able to get it in a timely fashion, the productivity will dip. And that is the story that's common across many organizations around the world when they're adopting any type of platform. Now, today specifically, we're talking about Vault, and that story can be said about Vault as well as any other platform out there. But before I continue, please allow me to formally introduce myself. So as I said earlier, my name is Rob Barnes. I am a senior developer advocate here at HashiCorp, and my focus is primarily on the secure product line. Hence why I'm talking to you today about HashiCorp Vault. I'm also looking at things like HashiCorp Boundary and, generally speaking, any workflows where security is a concern. Prior to me working at HashiCorp, I was an independent consultant. So a lot of the stories that I tell in my talks are based on my observations in the real world and my experiences. So now that you know who I am, let's continue with this talk. Now, I did mention HashiCorp Vault was not exempt from the story that I told, but just in case you're wondering what HashiCorp Vault is, I'm sure many of you do know, but for those that don't know, we'll paint the picture for you so you can understand the type of business value it brings. So, as an application developer, when you're developing your applications, you may need to interact with third-party services. And generally speaking, your applications will need to authenticate with these third-party services, essentially prove its identity. And that tends to happen using some type of API token or client token or something like that. Now, if you was to place this within your application, then your application becomes very insecure. It's now a challenge of open sourcing the code for that, because anyone that has access to that code base will see that and it could lead to a breach and many other security incidents. So essentially, you do not want to be doing things like storing these static secrets within your application code. The other challenge here is that the more places that this static secret needs to be in, the more places it's sprawled in. So if you ever get to a situation where you need to rotate that, there is a lot of work to find every single place where it has been used for you to rotate that. So Vault takes care of that for us, because now what you do is you will place that secret in Vault, which is a centralized secrets management platform in this sense. And your applications will call Vault using an API, because everything is API driven with Vault, and it will inject that secret at runtime into your applications, right? So it keeps your application code nice and secure. That's the first use case. The second use case is if your applications or even your team of developers need to, gain access to something like a database, for example. You could take the same approach. You could get some database credentials and place it in Vault as a long-lived static secret. The challenge with that is anytime where a developer has needed access to that secret, let's just say that there is an outage and they need to get into a database for a break fix scenario. They've now seen that credential, right? They may have written it down somewhere, and we now have the same kind of secret sprawl issue that we mentioned before. Also, it's a security issue because, if this developer leaves and they still have knowledge of your database passwords, this can be deemed as a big security flaw. So where Vault comes in to solve that challenge is it has the concept of dynamic secrets. Now, what this is on demand, it will generate short-lived credentials for the database in this example. So you would say to Vault, I need to access this database. Now, if you're authorized to access that database, Vault will go into the database, create a credential for you, and give you the details. You can then log into the database. But these credentials are normally associated with a time to live. So for example, if it has a 1 hour time to live, after an hour, Vault will go to the database and it will remove that credential. So this significantly reduces the blast radius of that secret, being exposed into the wrong hands or just being left in places where it should not be. So we can think of Vault in that sense as an identity broker. So we've looked at secrets management as kind of the angle of what Vault is, and now it's evolved into more of an identity broker. The other challenge that you may have as application developers is the need to, encrypt your application data. We live in a world of GDPR. We have to take extra care with our customer data. So most developers probably would not want to implement their own cryptography within their applications because it's complicated, it's prone to errors. There are so many different things that can go wrong. Well, this is where HashiCorp Vault can again come in and help with this challenge. It offers an encryption as a service method. Right? Now, everything is API driven in Vault, as I mentioned before. So essentially, you can go to Vault with your application data and say, hey, I want to encrypt this data. And Vault will send you back the encrypted payload. You can also do the reverse of decrypting as well. It supports most cryptographic actions out there. So data sign-in and verification, HMACking, and most importantly, it manages the entire lifecycle of your cryptographic keys. You can also do things like format preserving encryption as well. So when you think about that, you have cryptography as a service, you have identity brokerage, and you have static secrets management. You can do other things within your application. Like let's just say people need to authenticate to your application and you have a username and password. If you want to add an extra layer of security, multi-factor authentication is the common pattern that is employed today. Well, Vault can act not only as a one-time password generator, but it can also be a one-time password producer as well. So essentially, if people need to log into your applications, Vault can implement the workflow that allows people to either get the one-time password that they need to as their second layer of authentication, or it can actually be the basis of what is requiring that one-time password so that your applications can have that extra layer of security. So with all of this context here, I'd like you to think of Vault not only as a secrets management platform, not only as an identity brokerage, not only as cryptography as a service, but I'd like you to think of it as a standard library for security. And you are delegating a lot of the responsibility for security back to Vault. So with that context, we now understand what Vault is. You can understand how important it will be once developers start to adopt this into their teams, into their applications. Your applications are going to have a huge reliance on being able to onboard things quickly and being able to access secrets and being able to change things as your applications evolve. And if you have a reliance on a centralized team, then it becomes a bit more problematic and it's a barrier to adoption. With that in mind, let's take a look at what the problem is. So if you take a look at the organization flow here, you have this centralized team here, and they are responsible for managing Vault in this case. So any changes that need to happen to Vault, you put in a ticket or a request to this team, and they will go ahead and action it. And you have all of these development teams that have this reliance on this centralized team. And obviously, as we've identified from the story earlier on, that is a bottleneck in the process. So how we can get around solving that problem is to employ a different model, which we call the delegated administrator model. Right? And what that means is all in the name. You are going to delegate the administration of Vault to chosen administrators. And Vault makes this possible because it has the concept of namespaces. Now, namespaces, if you come from a Kubernetes world, it's going to operate a bit different to what you're used to. I'd like you to think about a namespace as an individual instance of Vault. So rather than having one centralized Vault that everyone is using, you almost have your own Vault for each team or each product, however your organization is divided up, right? And the person responsible for managing that namespace or the mini Vault is going to be the delegated administrator. And this is where you as SREs come in. You play a key role in this delegated administrator approach. Now, as a delegated administrator, your main responsibility here is to enable and empower your teams to be productive in a secure manner, right? So how would you go about doing that? There are a number of things that you could do. So for example, when it comes to authenticating your applications to Vault, maybe you use a particular pattern, which every single application uses that. Where every time a developer is onboarding a new application, they will need to remember how to write the code that's going to authenticate with Vault. So maybe it's a good idea for you to write code snippets so that anytime a developer needs to authenticate with Vault, they can just grab this piece of code and just add it in, and away they go. This could be for any type of interaction with Vault whatsoever. If you find common patterns, then maybe create a code snippet. Further than that, maybe you want to go as far as creating a client library, which your teams of developers can use to realize the benefits of Vault within their applications. Now, we do have some SDKs for Vault. So we have an officially supported Go SDK as well as a Ruby SDK. And in addition to that, there are a series of community supported libraries out there for different languages. So from Java to C# and Python, there are so many libraries out there. And that works for some organizations. Their security posture allows them to use these community supported libraries. But for some organizations, it's not going to be an option. So if that's the case, and maybe you're not using one of these supported languages in your application stack, maybe you want to write a client library internally for your organization, which wraps around the API. And this will make your developers' lives a lot easier if you have a well-written client library, right? So if you find that you're doing things all the time, maybe using certain patterns, the client library can be very bespoke to the way your organization works. Alternatively, as your teams are using some of the community supported libraries, if you run into issues or limitations, then it would be good practice to contribute to that open source project and just take your use cases in mind and submit some pull requests. So that's a key part of what you can be doing as a site reliability engineer, or in this case, a Vault reliability engineer. The other thing here is, as the delegated administrator, you will have most intimate knowledge of the identity and access management requirements of your team and its applications, right? So you will know who in your team should be accessing what sensitive or secret information, and you should know which applications require access to what secrets. So this places you in the best possible position to write identity and access management policies, which will be a key part of your role. As you onboard applications, if an application needs certain access to a particular database, well, you'll need to write a policy which enables that application to do that. And you can work with a centralized team to upskill yourself with these things here, but ultimately this will be your responsibility, as you will always have the most knowledge of the inner workings of your team and the applications, more so than a centralized team. All right. So the other key thing here is onboarding the applications itself. So how are you actually going to onboard the applications? So rather than waiting on this centralized team, you can just do it yourself because you are the delegated administrator. We have to remember, we're not onboarding the applications to Vault, we're onboarding it to our namespace, which is our mini Vault, right? So we have complete control and autonomy. When you're onboarding these applications, it's always a good idea to empower the rest of your development teams so that in your absence, they can still onboard applications without any single point of failure or reliance on an individual being present. This way you can enjoy more vacation time. In addition to the identity and access management policies and the onboarding, in general, managing your namespace is always good to do it in code, right? It keeps things nice and repeatable, and where possible, try and use tools which are idempotent, so you can run things over and over again and you will only get the desired state. Nothing should change if you run it multiple times unless the desired state has changed, right? And the best workflow in my experience of implementing Vault in so many organizations is to use tooling integrated with a CI/CD process. So it's always good to submit pull requests, and it will kick off a CI/CD process which will implement your changes into your namespace, right? So how you go about doing that, if you decide you need quality and approval gates, then that's entirely up to you. How you design your CI/CD pipelines for Vault is a very bespoke exercise, which is down to your business and security posture. But essentially, the approach of using a CI/CD pipeline to deliver your changes to Vault is an important step. And as the delegated administrator, you will be responsible for implementing and maintaining this CI/CD process. It's also important to use this as an opportunity to enable self-service. So if there are repeatable things that your teams of developers could do for themselves, then this will allow them to submit a pull request and their changes will be in there without a reliance on you having to deploy these changes yourself. If you're using tools like Terraform, for example, to configure your namespace, consider building modules. And the reason why I say that is because modules, just like our functions in our application code, can be nice, repeatable building blocks. So if you have a module for a particular configuration of an auth method, you can literally take this building block and apply it. And it means that should other developers need to make changes within the Vault namespace, they can literally take modules which you've written in a very opinionated way, and it's as simple as filling out a form and deploying it to your version control system. Your CI/CD process takes care of the rest in terms of the deployment. So it's a good way of enabling self-service within your teams. Finally, as SREs that are embedded into multiple development teams, you are going to encounter a lot of different experiences. You're going to acquire very unique knowledge, and you're going to run into particular nuances and use cases. It's very important that you capture these things, and even more important than capturing them is to share them with your fellow SREs, right? So let your fellow SREs learn from your experiences. So there are multiple different ways of doing it, and it all depends on the culture within your organization and the things you're comfortable doing. So it could be writing a blog post if you have a particular use case and you were able to solve it with Vault in a certain way. Maybe have an internal wiki. So kind of think of the HashiCorp Vault documentation that we have online. It could be a good idea to have your own internal documentation based on your bespoke usages and experience. So you can contribute to these things here. It could even be speaking at an event like this, just like I'm speaking to you. There's a lot of value in sharing your experiences. And just remember, we are stronger together. And on that note, I'd like to end this talk here. Thank you so much for listening, and I hope you found this useful. Please enjoy the rest of the conference. I'm Rob Barnes, and it's been my pleasure to speak to you today.